let's just go ahead and get started with lesson 16. I'm still pulling up my stuff here.
Okay.
Rachel, do you have any ideas on what we should do? Does anyone have ideas on what we should do for our group project?
I started thinking about that. I didn't look too much into the description of it. Do we just pretty much pick like a topic and?
I think so. What do you think, Jessica?
I think whatever we do, that food will probably be the easiest.
Yeah.
That seems to be where I see most of the examples come from.
Yeah.
Like, even the example at the beginning of the semester with the cookies in the bag, like with the pink ones and the white ones. Or, I don't know, do you guys watch the videos that go along with the sections, with the lessons?
Yeah.
Yeah, so like,
yes, I do.
About the peanuts in the box. It just, I think something with food would be easy.
Yeah.
But still interesting, you know.
Yeah.
Mm-hmm.
Okay. I'm okay with
And another one that I was thinking about too that we could do is like picking a certain color of like cereal boxes and just going down to see. I don't know if that would be too hard to count all the cereal boxes and all that kind of stuff, but something that has to do with that. I don't know.
Color.
That would be fun.
Yeah. Okay. Anyway, so whatever.
With, like, the color of M&Ms.
Yeah. Get a bag of M&Ms and see what percentage of blue M&Ms are in there or whatever.
Yeah.
Something like that.
Yeah, that would be fun.
Okay. That sounds good to me because we can all get a bag of M&Ms and count and calculate and stuff and just specify the size of the bag, and I think that would be nice. And
yeah, I think that we should use a bigger bag of M&Ms just because bigger sample size that way.
You mean like not the snack size, but like a regular.
Yeah, not like the little ones that you get, but like an actual, like, I don't know how many ounces it is, but
okay.
Yeah. Okay, perfect. That sounds great to me. Okay, whoever gets it first. I'm still pulling up, so whoever gets theirs first, we could just go ahead and start, and then I'll catch up when I get there.
Okay, I've got mine open, but it wants me to pull up a data file, but there's no link for it, so I'm trying to figure out how to get the data file.
Oh. That's what I had a problem with that on one of my assignments too. I don't know.
Oh, so sometimes it's in certain sections of the book. So I think I downloaded all of them.
Oh, okay.
But I have to figure out where I put them.
Okay.
Sorry, my internet cut out. What did you say, Jessica?
Oh, all of the data files that we use for all of the assignments can be found using links to the book in certain chapters. So I'm going to see, I think this last chapter had one of them.
Okay.
Let me see if I can find that. They're usually with the
yeah, it's through a textbook link.
Okay, so I found where it is. If you go to, have you found it?
Yeah.
I haven't.
Yeah. Okay.
I have not. Where did you find it at?
Oh, so if you go to the book in chapter 14, and I'm sure it's other places, but if you go down to where the blue part where it shows you the SPSS instructions,
okay,
then you click on whatever data file that they give you, and it opens up a thing where all of the different files are.
Oh, okay. So lesson 14, and it's in the textbook or the online textbook. Okay.
Oh.
And you said it's on the bottom?
If you just scroll down to where it shows the SPSS instructions, so it's about halfway through.
Okay.
And the specific one that it says for the chapter 14 or lesson 14 is the gratitude stacked. But when you click on that, it takes you to a page that has all of the files, and you just click on the class survey.
So is it okay, so quantitative inferential procedures XLS? Is that the one?
The one I have is class survey.
Oh,
that's what it says for the lesson 16 prep.
Oh, okay, okay.
The class survey one.
Okay. Okay. I think I found it, but let's see here.
Oh boy, there's a lot of stuff on here.
So I'm look at my SPSS program, and it doesn't have the same instructions as the other one. Like when I go into graphs, there's no pie chart option, and there's no legacy.
With the one that you have?
So I don't know if I'll be able to help with the SPSS.
What I've been doing, because I don't have the SPSS, it doesn't download on my computer, I can't do the VMware, it just doesn't work. So what I've been doing is I've just been following the Excel problems, the Excel stuff, and it's worked just as good. So I think that, Renee, if you have the SPSS and then I have the Excel, and we can kind of double check.
I think cover all our bases, yeah.
Yeah.
Okay. Are there Excel directions in the text?
Are the Excel directions in the text? Yeah.
Yeah.
So you can totally do that too.
Are the SPSS instructions weird?
They're what?
When I open chapter 16 in the text, it only comes up with SPSS instructions. There's no.
I watched the videos, and in the videos it showed me how.
Oh, okay. I need to do that. I haven't watched the videos yet.
Oh, and I see the Excel instructions on the lesson 16. It's up at the beginning of the page. Right under section 2.2.
Yeah, mine only has the blue SPSS instructions. There's no Excel.
Oh, that's really weird.
Yeah, that is weird.
Okay, so okay, I got the files now. They're up now.
Okay.
I don't know why I keep on Xing it as, but I do. Oh well. Okay. All right. Now let's see. Lesson 16 prep. And where is that? There we are. Okay. All right. So class surveys. And I love that the applet or the Excel spread that they created for the intervals. I'm like, this is so easy. You don't have to like calculate it longhand or anything like that. So it's like
I know.
a dream.
Like stick the stuff in.
Yeah.
Okay. So for this one though, you have to actually make the pie chart.
Yeah.
Okay, let's do this. Okay, so yeah, I'm doing a fairly good job of remembering how to do all of these different things, but I have had such, like this homework assignment, they didn't really have very much, give us very much opportunities to experiment, and the only one time they did, I couldn't find the file, so I'm like, okay, forget it, I'm not doing that, but
Yeah.
okay, so here we go. So this will be fun. Okay.
Yeah.
Okay, so the class survey, then so open the file, and we did that. Create a pie chart for class rank and label it. All right, so hold on, let me get the top of the file here so I can see what each, okay, so class rank. All right, let me just highlight that. I'm sorry, it's just what I feel like it's so slow for sometimes, but anyway,
Yeah.
it's opening up the IBM the SPSS file, so we will eventually get there. Okay. For whatever reason, when we use the IBM, well, it's because it is a desktop on top of a desktop, so it's like a facade, and so it's just super sluggish, and so it's kind of tough to do. But anyway, okay, so here we go. So we're going to do graphs, legacy dialogues, and we're going to do a, wait, I think that's right, pi. Okay, class rank. Okay.
Your presentation.
Okay.
One of the things that you needed.
Addie, will you go check that thing?
Okay.
Yeah. Okay, so yeah, it's, I don't know. Create a pie chart, and so now I'm gonna just double click on the individual so I can do the chart editor thing and figure it out here real quick.
It melted all the way.
Okay, that's fine. No.
I'm gonna put the tomatoes in, right? Do I have to cut them up or anything?
No, you don't.
Where's mine?
Okay. Oh, thank you. That's nice. Thank you. I'm gonna put it right here. Okay. I'm getting my notes because I can't remember what I'm supposed to. Okay, so the pie charts, and then you do the legacy dialect pie, and then so the default is the summaries for group of cases. Okay.
Are you gonna do like Hi, my name is David.
Hi, my name is David. I am baby. I was born like, I have older sister Judy who's Stephen.
I don't know. I mean, it just wants us to paste them on there, so I don't think we need any.
You need what?
I don't think we need any more information. We're just supposed to paste them onto our homework file.
Yeah, I think that's
Okay.
too. So, I was able to do the bar graph for number 7.
Okay.
And that's kind of the same thing where you just pull it up and paste it. And then number 8 wants you to use 5 descriptors to describe the data.
Okay.
So if you want, I can read to you guys what is on the chart. But it says on the answer sheet that you can use, like, you can describe the sample with words or a frequency table or just like any way that you want to describe it, you can.
Okay.
So the chart I pulled up, there's 5 of the ranks, and then I don't know what the first one is. It's like at 1. And there's freshman, junior, sophomore, and senior. For freshmen, it's a count of 10 people ranked, and then junior is 60, sophomore is 70, and senior is about 40. And then I pulled up one that has the percentages on there. So freshman makes up 5%, junior makes up about 32%, sophomores make up 40%, and seniors make up 22%.
Yeah.
And then you can describe it by saying that it peaks at sophomore year, like it's like bell curve, where sophomore year is the highest part.
Mom, is this done? Mom. No, sure. We need to have time.
I can't really remember what the statistics are.
Sorry, say that part again.
I can't remember what all the descriptive statistics are, but we could just come up with like I can come up with. Oh, there we go. I'll come up with the mean.
So for the categorical data, this is, how do you know what the mean is? Does that make sense? Like, just from looking at these, is it just the middle, the one that's in the middle?
That's a good question. On SPSS, it gives you an option to calculate the mean of a bar chart. But I think I did it wrong the first time. Let me try again. I just don't know what the variable is.
Are you registered?
I think so. Baby, I got a push.
No, don't talk now. For your questions, come ask me.
Do we want to go on to number 9, or are we still?
I'm okay with you.
Yeah. I think we can go on.
Okay, cool. I'll read this one. 7% is the true unknown percent of the population. do not have traditional phones and instead rely on cell phones. 7% is P. Suppose a random sample of 750 telephone users is obtained. What is the probability that more than 60 cell phone users, 8% in the survey, use only cell phones? Okay.
So this
So
is the
then,
formula where it's divided by whatever the I don't remember what.
so then for this one we would do 0.07 minus 0.08. Is that right?
The formula equals x divided by n. So
Oh, okay.
Oh wait, which number was that? N is
Do we have an X?
Well, I think the six. They want to know what the 60 are.
Yeah, the 60.
I'm getting like tons of feedback. Do you guys hear my feedback already?
No.
Okay.
It's not too bad.
Okay. But yeah, I think the 60 would be the
Would be the X.
yeah.
So 60 divided by 750. That's where they got the 8%.
Yeah, that's what's throwing me off is the 8%. So we're supposed to solve for 8%.
We're supposed to solve for what?
Do they want us to use the 8%?
Sorry, I missed those last couple words you said.
No, that's okay. Do they want us to solve for the 7% or the 8%?
I'm looking at the key right now. So for A, the question is, what is the mean and standard deviation? So I guess of the sampling distribution based on 750 telephone users. And the answer says that the mean is 7%. And the standard deviation is 0.0093. So in the problem, it says 7% is the true unknown percent of the population. So I think that's where they get the mean. So they're just asking us to identify that information.
Okay.
And then the standard deviation that's like the square root of P times 1 minus P over N, right?
Yeah.
Okay. So then we would use 0.07 as the P. Yeah, and when I put that in, I got the 0.0093 that they have on the key.
Oh, I might have done it wrong.
With stuff like this, I always just kind of start on the inside and move out. So I do 1 minus the thing times 1 minus the mean.
Okay. Oh. I found my mistake.
Okay.
I'm going to turn I'm turning my microphone off because there's tons of feedback. I'm sorry. You guys just can talk and I'll listen this time.
Okay.
Sorry.
Okay, sounds good. So is that what you got, Rachel, for the standard deviation is the 0.0093?
Yeah, yep.
Okay, cool. So let's go on to B. It says state the problem in terms of the variable. So the variable for this is p hat, and
Which we decided p hat is 0.07, right?
is what?
0.07.
Yeah.
Okay.
And then this isn't making sense. What it has on the key. Are you looking at the key too?
Yeah. Let's see, P is 7%, and then the difference between P and P hat is
So P is 7%, and then P hat is 8%.
I don't know what P is. I know that divided by 7 is 8%. So whatever P hat is 8%.
Is going to be greater than that.
Yeah, according to the but
Yeah.
I'm trying to remember what P hat is.
Me neither.
That's
No,
weird.
it says P hat is X over N, which is 8%.
So they should be equal, not greater than.
Yeah, that's weird. Oh, what is the probability that more than 60 phone users in the survey use only cell phones? So we're finding the part. So like if we were to use the applet, we would highlight whatever is greater than 8%.
Oh,
That's where that comes from.
That makes sense.
Okay. Draw a picture, the normal curve, and shade the desired area. So that's what we would have done.
Yeah, with the normal
Is everything that's greater than 0.08. Okay, cool. Convert the values of p hat using the standard normal variable z. Find the z-score. So the z-score, it's p minus p hat, right? Or is it the opposite way around?
I'm trying to, I don't remember.
Let's see if I can find it.
It's p hat minus p.
P hat minus p, yeah, okay.
Sorry,
so 0.08 minus 0.07.
So we get
Okay.
1%.
Over the standard
Divide
deviation
that.
we're calculating already. Yeah.
Yeah, so the 0.0093.
Yes.
So I got 1.075, but that's different than what this says.
That's what I got.
Yeah. I don't know why they.
It just must be a typo. There's no way that all three of us got that same answer.
I know. Well, and not only that, but that happened in an earlier one I had too. So, I don't know.
Yeah.
I took the
3 and
homework quiz
5
and I got it right on there, so.
Okay, and then the area.
We take our z-score and plug it into the category.
Yeah. Okay.
Where's my phone? Addie, do you have my phone?
You want to see this picture of
So with this one, it came out 1412 instead of 1416.
That's what I got too.
Yeah.
You still just highlight what's inside.
Yeah, but I just put in the 1.073 like it says on the thing, and it comes up with 0.1416.
Okay. Yeah.
Yeah.
So I think that just some numbers are mixed up there, but we know what we're doing, so I don't think it's a problem.
Yeah. And I think it could be a matter of rounding or something like that, so.
I don't think it's a matter of rounding, because I have a pretty nice calculator that I don't have to round things before I do it, and that was the number that came up.
Yeah.
So.
Okay. Yeah, I don't know. It must be a typo then.
And then to interpret the data, so that means that there's a 0.1416 chance that 8% or 60 phone users use only cell phones. Is that what it is? Yeah.
Okay. Good.
Cool. Do we feel ready to take the quiz?
Sure.
Great. Have you guys gotten to the quiz yet?
Yeah.
Okay. I can go ahead and start reading number 3, which is kind of funny. But in a pie chart, why are the slices different sizes? I like the first answer. It's just kind of funny. But
Yeah.
each slice represents a
second one.
category in the area. Of each slice represents a proportion of the total occupied by the category.
Yeah. Okay, and then number 4, it says are the bar chart and Pareto chart related? It's identical. Pareto charts are constructed from tossing a coin several times, or the only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are ordered largest to smallest, going from left to right.
That last one's
And
the answer.
that's last. Yeah, that's right.
Okay, we conclude that that is distributed if NP is equal to or greater than 10 and P is greater than 15.
Yeah, P is the true proportion.
Yeah, P is the true.
What is
The sample size.
Okay. Because X is the number of successes, right?
Yeah.
Okay. That's what I thought.
So then for number 7, if P equals 1/4, what is the smallest N that satisfies the requirement, and that would be 4. Right?
I don't know because I got that wrong on the quiz.
Doesn't it have to be a positive number, like a whole number?
What?
Be a whole number.
It has to be whole.
P or N.
Because P is calculated by using x over n. So in this case, if P equals 1 over 4, then x would equal 1 and n would equal 4. But there's several different ways that you can get 1/4. You could have 2/8 or 2 out of 8 or whatever. But I think that because the numbers have to be whole numbers, you can't take they don't want you to take half of something. Then 4 is the smallest sample size that you can get.
Okay.
Where you just choose 1 out of them.
Okay.
I think
that's right.
That's how it's
that sounds right.
making sense in my head.
Well, my gut reaction when I was like the number P equals 2/5 or something like that, and so my gut reaction was to put 5 down, but I was like, no, that's might be wrong. But so I'm thinking it might be 4.
Did you put 5 before?
I didn't put 5 because I put 2 other figures, and one of them was a fraction because I was trying to figure out how I can make it equal to 10. Because I was thinking that 10 was the number, and that's not right. You know the requirement, how it has NP is greater than or equal to 10. I put a fraction in because I was trying to figure out if it was supposed to equal 10 or greater, and that was not correct. And so the only number I didn't put down, because I only had 2 chances, was the denominator of the fraction. So
okay. Then
I'm third choice.
Yeah, I'm almost positive it's 4 then, because there's a couple it
okay.
4, 8, whatever. It could pretty much be any number that can be evenly divided by 4.
By 4, but let's just say that.
Yeah,
because that's the lowest common denominator.
Yes.
Okay.
Yep.
Okay. Good. I'm doing 4.
Okay. Me too. Use the following information to answer questions 8 and 9. Suppose that n equals 24 and p equals 0.4. What is the mean?
Okay. And that's 0.4, isn't it?
I don't know.
Because the mean in the equals the true proportion in this situation. But in order to calculate p-hat, you would have to have x over
the n. Okay, yeah, that makes sense. So in this case,
well, then I'm second guessing myself. So now is it 0.4 over 24? No, that can't be right.
That can't be right.
I think it's 0.4.
I think you're right. I'm just trying to find where it says that.
Yeah.
Section 3.2.2.
3.2.
Yeah, I wrote down from the notes. It says
okay, yeah, I see that.
Of p-hat equals okay, and then the standard deviation is that formula p-hat equals p times the 1 minus p over n radical.
Yeah.
Okay.
So then we're putting that p-hat equals 0.4. That makes sense.
Yeah.
Okay. And then the standard deviation is
0.4 minus or times 1 minus over n, which is 24, and it's all radical. It's the root of it.
What did you guys get?
I got 0.1.
That's what I got as well.
Yeah.
Okay. Okay. Use the following information to answer questions 10 to 13. Brittany's batting average is 300. We want to determine the probability she will get more than 35 hits and 100 at bat. So N equals 100 and P equals 0.3. So what is P? It's the same. It's the equals 0.3.
It's the 0.3, yeah.
Okay, and the standard deviation, let's just calculate that here. Okay.
What did you guys get?
Hold on, my calculator's not working all of a sudden. Hold on, let me redo it. Okay, I got 0.045825, whatever.
Yeah, so 0.046.
Yeah.
Number 13, what is the Z-score? 13, not 13. 12.
Okay, so for this one, we take 35 over 100. So 0.35 minus 0.3, right?
Okay, so yeah, the P hat would be calculated 35 over 100. Yeah.
And then it's P hat minus P.
Yes, which is 0.35 minus 0.3. And then we already figured out the standard deviation right there.
0.046.
Yeah.
So with that, I got 1.087.
That's also what I got.
Yeah, me too.
Okay.
Okay, now I'm sure they're going to want the probability. So
The p-value. Yeah. Okay, what is the probability Brittany gets at least 35 hits in her next 100 at bat? So then for our z-score, we put into the applet. So if it's at least, then it's greater than or equal to. So I have 0.139.
That's what I got.
Yes. Okay. If the true proportion of people who support a political candidate is P equals 0.52 and if N equals 2,000 people surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. Okay. What is the standard deviation of the hat? Okay.
So for this one, we use, because the mean is equal to p hat, we do 1 minus 0.52 times 0.52, right?
No, they want to know why, what
The standard deviation.
they want to know the 50%. Isn't that right?
I think that by the end they want us to know the losing percent, but that for this specific question, they're asking
It's
for
a
the
52.
standard deviation.
Okay.
So then, like in this one, in 14, they ask for the standard deviation, and then in 15, they ask for the z-score, and then 16 is when we use the probability. We decide if it's greater than or less than. Does that make sense?
Okay.
I think that for 14, it's just the standard deviation.
Okay. Then I'm going to
What did you
recalculate.
guys? Oh, okay.
Oh. Okay, so I got 0.0111
That's what I got as
for
well.
the standard.
Sorry, I'm almost there. I got.
Say that again.
I got 0.0111.
Okay.
Yeah, that's what I got as well.
And then I calculated the z-score already, and I got negative 1.18. Does that sound right to you guys?
Just a second, I'm almost there.
Okay.
So the z-score is the p hat minus p. And how did you find the p hat value?
Okay, so the p hat is I just used the 50% because it's a 50-50 chance that a candidate will win a vote.
Oh, so we're using 50. Okay, that makes sense.
That's what I think it is, because they don't have any other X or anything like that. So that came up a couple of times during the notes in the text. Like a coin toss is a 50-50 chance, and a candidate has a 50-50 chance of winning. So that's what I feel confident about that, but I'm not.
Yeah, no, that totally makes sense. I was thinking back to like where we had to do. For some reason in my head, I'm thinking that the X is equal to P, which is not the case. So
Yeah,
I'm
not
getting
here.
mixed up. Yeah.
Okay.
Yeah.
So what was the answer? The negative 1.82? 819?
Yeah. 818. Yeah.
Oh yeah, 818, sorry.
And I'm looking at number 16, and I don't really know. This doesn't look familiar to me. So.
What probability do you compute using the normal probability applet? So they're asking if we're going to shade everything to the right or everything to the left. So what we're asking, what we want to find out is the probability that the results of the survey will suggest the candidate is losing the election, which means he would get less than 50%.
Yeah. So it's the second one, maybe?
Yeah.
Okay.
don't even know.
So then it's 0.035 is the probability.
On that. Okay. I didn't even look at it yet.
Which makes sense because he's winning right now. So the probability of him losing would be less, or like a lower probability.
Yeah, that makes sense.
Okay, let me just verify. I'm going slow. Okay, so this you got 0.035?
Yeah.
Okay. All right, I'm on. Okay.
Okay, I think we're ready to submit.
Yeah.
Looks like we missed one. The 4. That's weird. And that z-score.
Yeah, I don't know. We're gonna have to. I'm gonna have to look at the Adobe Cast or something because I don't get that.
We also missed number 10.
Yeah, I'm surprised about that. Let's see. I don't know.
I'm wondering if something's off because I felt pretty confident about those.
I know number 10 and number 15. Okay.
Maybe that's why.
Round to 2 decimal places.
Yeah, because we only put 0.3.
Yeah, I guess so, but I never feel
shoot.
the need to add a 0.
Oh my goodness, seriously. That's it. That's crazy.
He did say that he would look at the group scores. So, like, if there is a problem, and if that's the problem, it's obviously not an understanding issue, you know?
Right.
So I think that we should have. I'm really confused about number 7 then, because I was pretty sure that was.
Well, when we entered it, the probability on number 17, we got it right, so I don't understand how that could be.
Yeah, for number 15. Maybe it's not negative, but I'm pretty sure it is.
That could be it.
Well, no, because if it was positive, then the probability, the area, would have been 0.966. So it wouldn't.
Yeah, I don't know.
There's no way that that's wrong.
Yeah, I don't know.
It must.
Anyway.
Yeah.
Okay, so let's go on to our 17. Yeah. Okay.
Okay. I am ready whenever you guys are.
Okay, I'm too.
Okay. Number 1 on part 2. I can go ahead and read that. The confidence interval in an October 2008 poll 684 of 1,006 randomly selected college students reported that they had been involved in an automobile accident within the last 5 years. Find the proportion for those surveyed who have been in an automobile accident in the last 5 years.
So is that the p-hat is 684 over 1,006?
Yes. Yeah. I was going to start calculating more things, but that's all we need right now.
Yeah.
So I got 0.6799, which is also what the key says.
Okay, good. Okay. And I'm going to use the handy dandy applet for this confidence interval since I like to be easy.
Yeah. I need to pull that up.
Okay, 684 with X and then 1,006 is N. Oh, you know what? I forgot. So on that one, we have to do the N times P is greater than or equal to 10, and N times minus P is greater than or equal to 10. So we check that.
Oh, yeah. Okay.
And then on the next one is the confidence interval.
Mm-hmm. Yeah, both of them are higher.
Okay. Okay.
Okay. So are we ready for C?
Yeah. I got the lower limit is 0.651 and the upper is 0.709. Tell me if you guys got that too, because then I might have to recalculate longhand.
0.651 and 0.07 or 0.709.
Yeah.
Yeah, that's what I got.
Okay.
But that's not determine the margin of error for a 97% confidence interval based on the data. And the number that they have here is 0.0288. Where does that number come from? Because we have, yeah, so we
That's
have the
weird.
margin of
Hold
error.
on.
Or we have the confidence interval, but the margin of error is that from the mean.
Oh. Okay.
So if we just do one of those numbers plus,
Okay. A little bit.
Yeah, I just heard you now. It's a little bit quieter than it has been in the past.
Okay, my screen is on screen right now, so I can't see. But I'll just listen till it gets again.
Okay. So we can go through and like calculate the margin of error, or, and this probably isn't like the best, but if we have the confidence interval, then we can take the bigger one and then subtract from that the smaller one, the lower bound, and then divide that by 2, and that will give us the margin of error, because the margin of error is in between those two values. Okay, so are we ready for, I guess, E, because we found the confidence interval?
Yeah.
Okay. How many college students should you survey if you want a 95% confidence interval with a margin of error of no more than 0.015? Oh, and there was a thing in here that told us the N, how to calculate for N.
Sorry, without the P.
Yes.
That one is the Z star over M, all in parentheses, squared.
Over 2M squared.
Yeah. Oh, yes, 2M squared. Okay.
And then that value of Z, those were given to us.
Yeah.
Sorry. Are they in the text somewhere, those values?
The Z?
Yeah.
It's 1.96. It's the 95% confidence interval.
Okay.
Yeah, that's the standard.
So then...
Okay, now this is the figure that we would round up, so 1158.
What is?
Were
Were you saying the answer that you got?
Yeah, the one, I think I got 1,158. Is that
that's
wrong?
not what the key says. I haven't finished calculating it yet.
Let me look at it now. Oh.
When I got it, I got 4,268.44. So
Okay, I'm
then
doing
round up
something
to
wrong.
4,269. What did you use for N?
Okay, so I used my margin of error. I used 0.0288. Is that wrong?
So the M is, there was a specific thing for it. It says the desired margin of error. So in the problem, it says confidence interval with a margin of error of no more than 0.015. So it's not saying what it is, it's saying what they want it to be. So we would use the 0.015 instead of the 0.0288.
Okay.
Okay. And if you do that, then it should give you the right answer.
Okay.
Okay. Okay, do we want to go on to number 2?
Yeah, sure.
Yeah, sure. Okay. Now you are interested in testing a claim that over 60% of all students have been in a car accident within the last 5 years. Use the same information as above and use a level of significance of 0.05. So A says state the null and alternative hypothesis. So the null is that P is equal to 0.6, and then the alternative is that P is greater than 0.6, because it's asking for over 60%.
Yeah, okay.
Okay. Okay. And then compute the test statistic. So we have to use the information from part A, where P hat equals 0.6799 minus P, which is 0.6.
So would we use 0.6 as our P to continue the calculation in the bottom?
Yes. Yeah, so you use 0.6, so you use P to find the standard deviation.
Okay.
Okay.
And then the number is 1006?
Yeah.
Okay. Oh, wait, it looks like we lost Rachel.
Oh, really? Oh. I wonder if she'll try and get back on.
Yeah, she could. Let me just send an invite to her real quick.
Yeah.
Down.
Okay, did you get a Z-score of 5.1?
173. Yeah.
3, yeah. Okay. Sometimes when I look at this on our homework quiz, there was one where it was like huge like that. It was like negative 4 point something. I was like, always worried. Like, oh my gosh, what did I do?
Like, there's no way that could be right.
I know.
Yeah.
Okay. All right, so let me put that in here.
I know, seriously.
So for C, it says determine p-value based on test statistic.
Yeah.
That's going to be like crazy low, right?
Super low. You can't even
You can't even see it. Yeah. Yeah, it's just 0.
Okay, so let's see. So it wants greater than, so I'm just going to make sure I just get that one side.
So then for D, it says what decision do you make about the null hypothesis? And because the z-score is, or the p-value is so low, lower than the alpha, we reject the null, which means that we have sufficient evidence to conclude that the true proportion, that 60% of all students have been in a car, that at least 60% have been in a car accident in the last 5 years.
Yeah.
And that's stated a little bit differently, but I think it means the same thing. So in the key it says we have sufficient evidence to conclude that the true proportion of students that have been in a car accident within the last 5 years is greater than 60%. Or a 0.6, I guess, if it's proportion.
Okay. Hi, Rachel. Okay. Yeah. Okay, we're ready to go on to the quiz.
Ready to, yeah. The symbol for the true population proportion is just P, right? And then the sample is the P hat?
Yes.
Okay. Are you guys ready for number 4 and 5?
Yeah.
My computer isn't letting me pull up or load the name, but you guys can go ahead and I'll just
What's that, Rachel?
my computer isn't letting me pull loading. You guys can go ahead and I'll just try and follow along.
Okay.
Okay, that's fine. Okay, so on number 4, is this the one where we do the NP is greater than, and we calculate, make sure everything is
That's
good
what
to
I
go?
thought, but I don't know the difference between what the requirements are for a confidence interval and what they are for conducting a hypothesis test. Are they the same?
Geez, I don't know. Let me see.
Because I don't
Okay.
remember any other kind of
I
requirements.
actually have notes. I have notes on that. But yeah. So what it is the requirements for a confidence interval is valid when p hat is greater than or equal to 10, and n minus 1 minus p hat is greater than or equal to 10. And then the requirements for hypothesis test is for one proportion is p. So the difference
Okay,
is
so the confidence interval is the p hat, and then hypothesis is p.
Yes.
Then I
So that's what we
calculated
learned.
for the hypothesis test, and that is true. They're both higher than 10.
Okay. Okay.
And then it's greater than or equal to, right?
Yes.
Okay, because n times p hat is just 10, but I think that still fulfills the requirements.
Right. Huh?
Okay, I can read the 6 through 8 thing. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Use this information for questions 6 through 8. So find p hat. The point estimate of the proportion of first-degree murder defendants who were found guilty in this state.
So that would just be the over the
Yeah, so 45 over 60.
Yeah. And then I got 0.75. I'm going to put 0.750 just because it's less way.
Yeah. I hate putting that extra 0 though. It's just a pet peeve of mine, I guess. And then the 95% confidence interval, we can use this fancy thing.
Yes, so I'm going to go ahead and do that.
Makes life super easy.
Yeah.
So 0.64 and then 0.86.
Yeah. Okay. So now we're going to increase the sample size to 80.
Mm-hmm.
Okay, what do you expect to happen with the width of the confidence interval? I got to look at my notes.
I said that, well, I would think that it would decrease. I could be wrong though.
Okay, so if you increase n, I know Rachel was good at this. I remember this last week and I got it wrong. I know. So when you increase the sample size,
you decrease the confidence interval because you become more sure, and so there's less margin of error.
Yeah, I'm trying to. I think the confidence interval.
I think that's right.
That's what happened. I calculated the differences.
Oh,
and
okay.
the difference when it was 80, when the sample size was 80, was 0.217, and then when it was 60 was 0.22. So they're very close, but it did decrease as we increased the sample size.
Okay. All right. Number 9, to conduct a hypothesis test in one proportion, the requirements must be met. Suppose equals 1/2. The smallest What is the smallest n can be and both requirements still be met? This is going to drive me crazy. I get this every time. What could it be?
And it's not talking about anything else. Okay. So if P is 0.5, so then it would be 0.5 times. Oh, okay. And the requirements still have to be met. So it has to be higher than 10. So if P is 0.5, then we have to figure out
20?
So then it would be 10 divided by 0.5, which is 20.
Okay.
I think so.
Okay, and then we have another chance to whack at this on number 10.
Okay, so then if it's 1/10, then let's see, we're gonna be doing.
Is it 100 then?
100 then? Yeah. It's 100.
Because 1/10 times 100 is 10.
Yeah.
Okay.
So I guess with all of these, what we do is we take 10 divided by the P.
Okay.
And that gives us the smallest. At least that's what's worked. So, I mean, we'd have to try
We're going to try it out.
Yeah.
Okay.
Yeah, that the requirements can still be met is the important part of that.
Yes, that equals 10.
Yeah.
Okay. All right, next section here. Okay, for questions 11 through 16, use the following information. For the water quality study and reading, about 60% of the macroinvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significance level alpha 0.05 with the following hypothesis. They collect new data, and this time NX 38, good health. Okay, the conditions are satisfied.
Okay, the hypothesis test is using P, yes? And then the confidence interval uses P hat.
Yes.
Okay.
And then so we do, the P is going to be 0.6, and the N is 80.
Yeah, so that's higher. Both of them are.
Okay.
True.
Okay, so now the P hat is the X minus X divided by N.
Yeah, and it's 0.475.
Okay. And then now let's just find the Z score.
Okay, so I don't know if my answer is right, but I have negative 2.282.
Let me just one sec. Okay, I got negative 1.8629 for the z-score. What I did is the p-hat, which was the 0.475 minus 0.6, and then I divided that by the square root of 0.6 times 1 minus 0.6 over 80. Could have very well miscalculated here.
Did you do the square root of that?
Let me make sure. Okay. Okay, yeah, I totally did something wrong.
Okay, so I'm pretty sure that I did it right, but I'm going to do it again just to double check.
Yeah, okay.
Okay.
Okay, negative 2.281. I think that's what you said.
282.
282? Okay.
Yeah.
All right. Now the p-value. And they want to know what's less than.
Yeah. So for that, I got 0.011.
0.011, yeah.
Is that what you got?
Yeah.
Oops, wrong space.
Okay. And then number 15, reject the null because that p is low.
Yes.
Okay.
There is sufficient evidence to conclude that the water quality in the area has decreased. So that first.
Yeah.
Okay, I think that's right. Success. We even got 9 and 10 right.
Yay. Okay. I think that's it. We're good, and I think we lost Rachel. She must be having problems with the connection.
Oh, okay. Cool.
So
so what do we need to do for this project?
She is in charge of writing up the project and submitting it. So
Okay.
maybe I'll just touch bases with her to make sure she can go on Saturday and make sure that's all good before we
Sounds good.
close the week. Thanks, Jessica.
Okay. Thanks. See ya.
Bye-bye.